So in the last video, the last two examples of sequences that we saw, I said we were going to spend some more time on those. So this is the first special kind of sequence we want to look at. It's called an arithmetic sequence, and this is a sequence where each successive term is found by taking the previous term and either adding or subtracting a fixed number. We're going to call that the difference or the common difference. Okay, so on the last slide we saw this sequence 4, 7, 10, 13, 16, and this is arithmetic because each successive term is found by adding 3 to the previous term. So 3 is our arithmetic or our common difference. All right, so let's look at this sequence. What is the third term of the sequence, which we'll denote with an A sub 3? So I just look, I have A1, A2, A3. So A3 here is 10. What about the 10th term of the sequence? Well, we could keep going. This isn't too far. A3, A4, A5. So I'm going to do some scratch work here. So after 16, I'm going to get 19, and then I need to add 3 to that. So 22, and then add 3. 25, 28, 31, 34. So that's A5, A6, A7, A8, A9, A10, whoops, A10, A11. So 31 is A10. But what if I asked you to find A100? You certainly don't want to have to keep adding 3 100 times. So we want to look for a pattern that helps us find the formula for the nth term. Just like on the previous video, when we had the sequence 1, 2, 3, 4, 5, and so on, we said, well, we could just say that A sub n is just n. Okay, so we're looking for a formula for an in terms of n. Well, actually, let's do it with this one, and then we'll do it in general. So I'm going to try to squeeze some work in here. I've got A1 is 4. How did I get A2? Well, I took 4 and added 3, and that gave me 7. For A3, I took the previous term, which was 4 plus 3, and added 3 again, which gave me 10. But notice that's the same as 4 plus 2 times 3. Now what if I want to do A4? Well, I'm going to take the previous term, 4 plus 2 times 3, and I'm going to add 3 again. Well, I have a 3 here and a 3 here, so I can combine these to get A4 is 4 plus 3 times 3. Let's go one more. A5, I'm going to take 4 plus 3 times 3, and I'm going to add 3 to that. So I have 3 3's here and 1 3 here. So this becomes 4 plus 4 times 3. And here I should pause and see if I can see a pattern. I'm going to switch my color so you can see. In fact, let me use a highlighter. Okay, so for A1 I just got 4. For A2 I got 4 plus 3. For A3 I have 4 plus 2 times 3. For A4 I have 4 plus 3 times 3. And for A5 I have 4 plus 4 times 3. If I look back up at the earlier ones, I could rewrite A2 as 4 plus 1 times 3. See if I can squeeze that in here. And 4 is the same as 4 plus 0 times 3. And so, whoops. The only thing that's changing here is this highlighted number that I'm multiplying by 3. And so in general, what do I have? Well, I have AN is going to be 4 plus something times 3. And the question is, what's that something? Well, if I compare my n to that something in each of these cases, what's the pattern that we see? Every time I look at my n, the something I'm multiplying by is 1 less than that n, right? I have 4 here, and I'm going to multiply 3 times 3 to get a 4. So in general, I want to multiply times n minus 1. Okay, so I get 4 plus n minus 1 times 3. And let's just check. For A10, that would be 4 plus 9 times 3. 9 is 10 minus 1, which is 4 plus 27, which is indeed 31, which is what we got before by just listing out the terms. Okay, so this is my general formula for the nth term of this sequence. We can do this in general for any arithmetic sequence. So let's look at how we would do that. I'm going to let A1, A2, A3, and so on be an arithmetic sequence that has common difference D. Then we want to get a formula for the nth term of the sequence. And so we're going to do the same sort of thing of writing out each term one at a time. So the first term is just A1. I get the second term by taking A1 plus D, my common difference. To get the third term, I'm going to take my previous term, A2 plus D, which I can rewrite as A1 plus D, and then plus D again, which is the same as, A1 plus 2D. And again, I can do the same thing. I'm going to take that term and add an extra D. That gives me A1 plus 3D for A4. For A5, I'm going to take the previous term, which was A1 plus 3D, and add D again. And that combines to give me A1 plus 4D. Right? 3D plus D is 4D. All right, again, we should recognize the pattern. It's the same pattern that we saw in the previous example, except now we have letters instead of specific numbers. So AN is going to be the first term of my sequence, A1, plus n minus 1 times my common difference D. This is a formula you'll want to have memorized. Okay. All right, I'm going to have you try to apply this formula in this example. So I want you to find the 52nd term of the arithmetic sequence with common difference 5 and initial term A1 equal to -2. So remember, when you see common difference, that's telling you that 5 is D. And here's your A1. And what is the 52? 52 is my N, right? That's the number term that I want. Now you have all the pieces that you need to plug into this formula. So go ahead and do that on your own, and then we'll come back and do some more examples.